Hello, I'm going to explain to you how to use SAS for doing one-way analysis of variance, one-way ANOVA. The task we will take up will be the adult one data set, and idea is we want to try and find if the ages of subjects vary across the different education levels reported. I would think the data set would not have any such effect, and I expect that null hypothesis may not be rejected. But I want to see if education has any effect on age as reported in the data set. And so our data set right now, we have education level and age. So let me go ahead and build an analysis using ANOVA, and it's going to be one-way ANOVA. Takes a while to respond. Alright, and I don't have any filter to do, so I'm not doing anything about the data set. And the tests we want to run, well, within the variables I want to set up, we need to set up a dependent variable and independent variable. The independent variable will be education, and the dependent variable will be age. Okay, and the tests I want to run, we'll revisit the test in a little bit, but we'll just go ahead and do the comparisons. Now it's going to we'll come back to visit the comparisons section, and let's display the mean and variance for each group, and we'll also do a plot the height bars, which are a lot of times used to display outputs of t-tests and ANOVA results. And the results themselves, if you want to change anything here, you can do that. Let me go ahead and run this. Alright, here we have the results. So the class level, education is the class level. There are 16 levels. So had it been just 2 levels, we could have used t-tests. There are 16 levels. ANOVA is a better way to do. And we have the descriptive statistics for means and descriptive statistics for each group. Okay, and alright, so the overall there seems to be some variation in the mean age. Okay, and the highest seems to be one is doctorate, 47, and the lowest happens to be something maybe 32 years, 12th grade. And this plot gives us kind of the high value and the low value for each group. Okay, and as you take your cursor over each data point, you get to see some additional information. Alright, now what does the results look like? Well, firstly, of course, the ANOVA result, this is the main ANOVA outcome, and it displays the sum of squares for each component. So the total sum of squares is 6,058,159, and the model sum of squares is nearly half of that, 317. Oh no, it's about 5% of that model, and as you can tell, R squared is about 5%, which is sort of low, and the error term accounts for the rest. So It's not a very strong outcome if you look at just the R squared, but overall the ANOVA null hypothesis that all means are equal can be rejected because the probability is less than alpha, less than 0.05, and so that means the null alternate hypothesis that at least one of the means is different from the others. Okay, now there is a way to find out which means are similar and which means are not similar, and to do that we need to go back to our model. So let's go and take a look at modify the model. Okay, no change in the data, but the tests and means. In means we have something called Waller-Duncan K-ratio t-test. It determines a multiple comparison test for main effect that you want in the output data set. So it also allows you to take a multiple comparison approach. So let me check that. Alright, and also other test we can run is the Bartlett and Brown-Forsyth tests. These are useful for testing for equal variance. And plots, we don't have, we already checked the means. Okay, let's go ahead and run this. Alright, here we have the results back here. And here's a result of the Bartlett tests for homogeneity of variance. So this means the variance in each group are approximately the same. Now that null hypothesis is rejected because we have a low p-value. So the test that assumptions of homogeneity of variance is violated because we have they're significantly different than the Brown's test. Okay, Brown and Forsyth test for homogeneity, that apparently is better to use. Okay, so it uses the outcome we want to use for ANOVA in this case. We'd use this result rather than the original result of ANOVA procedure, because this takes care of the failure of the homogeneity of variance test. So yet what we have is the p-value is still low, so which means the null hypothesis that all means are equal is rejected. And if all means are not equal, then are some means equal, some means not equal. That's where the pairwise comparison comes in. So later we have this we set up this means with the same letter or not significantly different. So some are different, some are not significantly different, and so it compares each education level with another one and finds that if you have group AAA, so doctorate and 7th to 8th grade education, they are not significantly different. These two numbers for doctorate education and 7th to 8th grade education is not significantly different. And also we have between B and between doctorate and 1st and 4th grade, it's not significantly different. So in other words, it tells us these ones are not significantly different, so the others are different. Okay, that's what it means. All right, and we have a whole bunch here. We have G, group G. We have HS grad, bachelor's, ASOC, VOC, 10th, and ASOC at ACDM. These are all 1, 2, 3, 4, 5. 5 of them are not very different from each other. So it not only does pairwise comparison, it compares multiple groups with one another, and all that is done for us. And now we can use this result to describe what we found. Alright, okay, I think that concludes the description of how we can use SAS for ANOVA, one-way ANOVA. Thank you.